Welcome back in the series of lectures on synthetic polymers. In this lecture, we are to deal with some important organic polymers. With this reference, we are expected to learn their synthesis and applications, their starting material and process of polymerization and applications. So, the expected important polymers are given in this list. Methods of preparation and applications of some organic polymers. These include polyethylene, polystyrene, polyphenyl chloride, phenol formaldehyde resin. So, let us begin with polyethylene. So, polyethylene is made by addition or radical polymerization of ethylene, which is olefinic monomer. Okay. Ziegler-Natta polymerization we have seen earlier, and metallocene catalysts are used to carry out polymerization of polyethylene. So, you go through the details of Ziegler-Natta polymerization, which is a free radical polymerization, and stereochemistry of the polymer is monitored. There are several types. The common types are low density polyethylene and high density polyethylene. Low density polyethylene is a thermoplastic. Convert these information into MCQs. Low density polyethylene is a thermoplastic made from monomer ethylene. It was first grade of polyethylene produced in 1933 by Imperial Chemical Industries (ICI) using a high pressure process via free radical polymerization. The reaction is N molecules of ethene under high pressure and temperature, oxygen catalyst, we get polyethylene, or that is polyethylene. Then second variety is high density polyethylene HDPE, is a thermoplastic polymer made from petroleum as one of the most versatile plastic material around. HDPE plastic is used in a wide variety of applications including plastic bottles, milk jugs, shampoo bottles, bleach bottles, cutting boards and piping. The reaction is again similar, but in this case the reaction of polymerization is carried out by using Ziegler-Natta catalyst. Let us see the comparison. The low density polyethylene is used mainly in film applications for both packaging and non-packaging applications. Other markets include extrusion coating, sheathing in cables and injection molding applications. Low density polyethylene is softer and more flexible than high density polyethylene. HDPE is rigid and durable and offers greater chemical resistance. Its higher melting point around 135 degrees centigrade allows it to withstand higher temperature than LDPE. It is more crystalline, it is having more crystalline structure and also results in greater strength and opacity of the material. There are several subtypes of these polyethylene. Okay. Ultra high molecular weight polyethylene, ultra low molecular weight polyethylene, high molecular weight polyethylene, high density polyethylene, high density cross-linked polyethylene, medium density polyethylene, linear low density polyethylene, etc. So, these differences are industrial differences and based upon their structure. Then polyethylene is used in applications ranging from films, tubes, plastic parts, laminates, etc. in several markets, packaging, automotive and electrical industry. Next polymer is polystyrene. As the name suggests, it is polymerized from styrene. So, polystyrene is a versatile plastic used to make a wide variety of consumer products. Polystyrene is made by stringing together or polymerizing styrene, which is a building block and it is manufactured to get various products. Styrene also occurs naturally in foods such as strawberries, cinnamon, coffee and beef. Of course, the percentage is that way comparatively low. These are the products obtained from polystyrene. Various products are available in market prepared from polystyrene. The reaction is, we start with benzene. Benzene reacts with ethene to get ethyl benzene. Ethyl benzene is converted into styrene. Okay. So, you can start from benzene and this reaction, alkylation reaction. So, it gives ethyl benzene. Ethylation product is dehydrogenated to get styrene, and styrene is polymerized to get polystyrene. The range of properties available along with the ease of processing make polystyrene a good choice for many applications. Unmodified polystyrene is clear, rigid, brittle and moderately strong. Its electrical properties are good, though it has relatively low heat resistance. Foam polystyrene can be more than 95% air and is widely used to make home and appliance insulation, lightweight protective packaging, surfboards, food service and food packaging, automobile parts, roadway and road bank stabilization system and many more. Okay. So, these are the various applications of polystyrene. The next polymer is polyphenyl chloride. We say PVC, polyphenyl chloride. So, polyphenyl chloride is a high strength thermoplastic material used in various applications such as pipes, medical devices, wires and cable insulations. It is the world's third most widely produced synthetic plastic polymer. The basic raw material for PVC are derived from the salt and oil. Chlorine is manufactured by the electrolysis of sodium chloride salt. These monomer molecules are polymerized, forming polyphenyl chloride. So, initially phenyl chloride is prepared and it is polymerized. For example, rigid PVC is like one of which is used in window frames is normally PVCU, that is unplasticized, that is a modified PVC. So, the reaction is N molecules of vinyl chloride. So, vinyl chloride is obtained from hydrocarbon and chlorine, we have seen. So, vinyl chloride on polymerization gives polyphenyl chloride. In all these polymers, you will find the difference only in the substitution. Okay. In polyethylene it is ethylene. In polystyrene one hydrogen is replaced by styrene benzene molecule. So, it becomes styrene and it is polymerized to get polystyrene. In PVC one hydrogen is replaced by chlorine. So, it is polyphenyl chloride. In polymer chemistry and material science, we are going to see the last application, that is related to resin. In polymer chemistry and material science, resin is a solid or highly viscous substance of plant or synthetic origin that is typically convertible into polymers. So, pre-fabrication, before fabrication the material is resin, after fabrication it is converted into a systematic polymer. Phenol formaldehyde resin or phenolic resins are synthetic polymers obtained by the reaction of phenol or substituted phenol with formaldehyde. So, the starting material is phenol and formaldehyde. These are used as the basis for bakelite. Phenol formaldehydes were the first commercial synthetic resins used in the industry. So, the reactions are like this. We begin with phenol, then we use second component as formaldehyde, HCHO, that is CH2O. Phenol and formaldehyde form this methylol phenol, orthomethylol phenol, that is the hydroxymethyl group is substituted. Okay. This is monomethylol phenol, this is dimethylol phenol, this is trimethylol phenol. So, methylation at ortho position, para position and 2,4,6 position. Okay. Then alternatively the process can be proceeded in this way. So, it will begin with para substitution, then you will get second and third product as shown earlier in the first reaction. Okay. So, this is called as methylation. Methylation gives methylol derivatives or hydroxy methyl derivatives of phenol. These are further polymerized. So, methylol phenol with phenol gives this compound. Then a similar type of reaction can be converted into more complex molecules. Then this set of reactions shows again the same. So, it is ortho-methylolphenol, this is dimethylolphenol, this is trimethylolphenol. Actually, methylolphenol is methoxy hydroxymethylphenol. Okay. So, these are the various reactions. Of course, these are shown on earlier slides also. Then these are further polymerized. Okay. On polymerization, the polymerization may take place in a network manner, 3-dimensional manner, or linear. So, in this way you will get the complex polymer, in this way you will get linear polymer. Linear polymer is called as no-lac, and the complex polymer is obtained in this manner. These can be fabricated in the form of bakelite. So, bakelite is very important due to its high resistance to electricity and heat. It is used in automotive components and industrial applications. Due to its excellent insulating properties, it is used for making switches and other electrical appliances. It is also used to make various kitchenware products like frying pans, etc. So, you go through these various applications. In short, we started with polyethylene. Let us see once again. We start from polyethylene, that is ethylene is polymerized to get polyethylene. We have seen the applications. Then we start, second is polystyrene, it has various applications. Then the third is polyphenyl chloride, and the last one is phenol formaldehyde resin. So, you go through these details, reactions and applications, and you will get the idea related to several multiple choice questions in these references. Thank you.